3D model with its execution schedule, which is time. So that make it complete 4D. So 3 dimension of space XYZ plus 1 dimension of time. Now 3D model is linked with the time to generate animation. To generate animation. So you will see that animation of construction of that particular structure or monument, or it is used in the complicated structure where, let's say, that interpretation of the drawings become difficult. Then 3D model is linked with the time, so you will see animation of construction. So that is used for that demonstration purposes. That is used for demonstration purposes to demonstrate things, so that everyone come to know that what is to be constructed exactly. So this is the, or if you see one slide before this, now this is the first, second stage, third, fourth, five, fifth. So this is the 3D plus schedule 4D. If let's say model has been developed in CAD, so that a 3D, it is also called sometimes 4D CAD. If let's say this 3D model has been developed in CAD, sometime it is also called 4D CAD. Otherwise, it's widely used term 4D in the construction industry just to demonstrate what is to be constructed. ठीक है, कोई और किसी ने कुछ और पूछना हो?
Yes, sir. I have a question, sir.
हाँ बोलो.
Yes, sir. I have a question. Sir, in Revit also we have a feature in which we can add topography to the our structure, sir, in which we can place our structure to according to the topography, sir. And there are other softwares like ArcGIS and the other GIS software. So, sir, which is better and what is the basic difference between these two, sir?
Okay. I will have to come to this question later on also, but just in brief, GIS is not a new technology. Okay, it is well mature technology to model topography. There are so many things or so many type of analysis which can be performed in GIS. There are so many, but nowadays the people realized that topography modeling is important. So they have introduced some part of it, just like in Revit or so many other software. So they have realized the importance of topography, but what the main software to model topography and do all these geospatial analysis, that is the GIS. Just like BIM is a technology, GIS is also a technology. There are so many software of GIS. Okay, ArcGIS is one software of GIS which is widely used in generally used by 70% of the people who use GIS. Same way, just like 80% of the people who use CAD, they use AutoCAD software. Okay, same way there are the 70% of the more about 70% of people who use this ArcGIS as a GIS software. और कुछ किसी को डाउट हो? ठीक है, आगे चलते हैं.
Okay, sir. Thank you, sir.
हाँ ठीक है. अगर आपको किसी को भी बीच में, मैंने क्या किया है इसमें, आई हैव स्किप्ड जो भी मॉडलिंग, मैथमेटिक्स या कुछ भी इक्वेशन कुछ भी नहीं रखा हुआ है. आई हैव मेड यू just just like text, okay, so that you can understand things. अब उसके बाद यहाँ पे ठीक है, slide number this one. ठीक है, up to this we have established that we need the best software which need or which is required to model building, that is building information modeling. Up second, now the utilization of building information modeling which we have established to support various tasks of building life cycle is growing very fast. This we will establish now. Okay, that utilization of building information modeling to support various tasks of building life is growing very fast. What are those various tasks we will discuss? Of a building for its lifetime, a building for its lifetime is an important part in its surrounding. Hence, its life cycle must not be managed in isolation. That is, as a single entity. Single entity means we cannot see that building in isolation as a single entity. That's mean without considering its participation in a building in its surrounding. So that's mean that now we are moving toward establishing the importance of surrounding. We are moving toward establishing the importance of surrounding. Now, first thing, अब देखो, before that, this one, what are the various tasks which this building information modeling support? Now let's see here, what is the title? Building information modeling in need of building life cycle. This allow so many professionals to planning, design, okay, constructed with just using one 3D model. I have told you we will make one 3D model, and that 3D model is used for cost estimation also, for making of front, side, plan, section, and for design also in BIM. Okay, this data or this 3D building model will be with the stakeholder also. It will be with the owner also, because later on, let's say once construction is over, that whitewashing is to be done, and from that 3D model, owner can calculate what will be the surface area. Let's say later on, heat ventilation and air conditioning system is to be developed. That owner can calculate what will be the volume of a particular room. So there are so many things in which this 3D model which we develop in BIM that will be helpful. So that means there are so many things that means BIM based applications, software, or frameworks give practitioner a broad view of use of BIM to support building life cycle. Up before this, or if you go around about 10 years back, the main focus of these people who are associated with the building information modeling was very good 3D model, very good editing capability to make 3D model, very good capability to generate section plan front view from 3D model, and that very good capability in the building information modeling to generate cost estimate from that 3D model. So those are now well matured. I repeat, 3D modeling capability of BIM or VBIT are well matured, and that model which we develop for visualization, that 3D model is also used for quantity takeoff and cost estimation. Then people realize that why not that 3D model which has been developed in the early stage for the building life throughout its life cycle. Then they come with another term, extended BIM, a solution for building life cycle, which is also called widely used term nowadays, ND modeling. ND modeling means nth dimension. So many things with that one software or with that one 3D model. Okay, I repeat. Now, first they realize that BIM industry realized that let us have very good editing, 3D editing and modeling capability in the BIM. Then they developed it. Then they thought that let us make a 3D model, and from that 3D model we may be in a position to develop front view, side view, sections, They they did that. Then they realized that that 3D model for the cost estimation, quantity takeoff, they also they did that. Then they thought that let us extend the application of BIM throughout the life cycle of that particular structure or of that particular building. So then new term extended BIM, or instead of 3D modeling or 4D modeling, then they developed a new concept which is called ND modeling. Okay? So ND modeling is an extension of building information modeling. Now just see, ND modeling is an extension of building information modeling done by incorporating maximum information. This is that maximum information in the building life cycle, which we can now if you compare different different companies have developed different BIM tools. They have different application area. Okay, so that means they are now trying to incorporate maximum information for building life cycle. Okay, so ND model is a database of building information that contain much more information from feasibility to demolition, mean all stages of a particular building. From feasibility mean when ideas are generated, we have discussed when ideas are generated by the owner and technical team may be architect, engineer, or planner, depending upon requirement and funds that particular owner has. So that this mean anti model mean a database of building information that contain more information from feasibility to demolition stage. So earlier they thought of initial BIM for initial stages. Now they are extending N applications from feasibility to demolition stage. So that another concept. Then some people placed another definition like this: ND modeling extends the concept of 3D to integrate enough number of information dimensions. This is another definition that 3D, I've told you 3D to 4D, sometimes 3D, 4D, I've told you three dimension of space and one dimension of time, which is called 4D. Sometimes people call 5D also. So they talk three dimension XYZ plus one dimension of time, which is schedule, fifth dimension of cost estimate. Now, long if you go 5 or 6 years back, people advertise like this: we have 5D BIM. 5D means it can do 3D, it can do 3D modeling, then it can make animation of by linking 3D animation 3D model with the schedule 4D, then it can create or generate quantity takeoff and cost estimation also to make it 5D. Nowadays, people are moving beyond this 5D to make enough number of information. Okay, to come for its complete life cycle, for its complete life cycle. Okay, so then people put it like this: majority of researchers suggest that BIM virtually use 4D modeling for building life cycle management. Building life cycle management. And the extension of BIM for food ND modeling to is to incorporate the type of information which need to be integrated in BIM for BIM to fulfill the requirement of building life cycle. Now, what are those N dimensions which may be like this? Few reported application of BIM to extend it from 3D to ND. Now you will say, what are those? Which include design. I've told you Autodesk has I Hello.
Sir.
Sorry, could be uh, so few few reported applications of BIM to extend it from 3D to ND include design. I have told you that we have now rebuild structure also, cost estimation. After making this 3D model, they have developed this cost estimation module also. You can do scheduling also. With that 4D, you can do constructability analysis also, safety planning, sustainability analysis, maintainability, and building evacuation simulations. These are the widely reported application areas to extend the use of BIM from 3D to ND. After that, building life cycle must consider the way by which surrounding influence life cycle of a building as well as again if we come back the way by which surrounding influence life cycle of a building as well as how a building is influenced by its surrounding. Now we need to consider that how surrounding get affected, okay, by the appearance of that particular building, or how that building affects surrounding, or how surrounding is affected by that particular building. Okay, to consider this, we need to have this GIS, Geographic Information System. Okay, so Geographic Information System is also used to support various tasks in the life cycle. Okay, other than also, there are so many application areas of GIS which support building life cycle, in which BIM is lacking. Okay, so in which BIM is lacking. So the effect of surrounding on a building life are considered by using GIS. So that's mean we need this introduction part. If let's say time permit, then we will discuss later on. But we need that's mean if we put thing like that okay, we have modeled building with the help of building information modeling. Now we need to model surrounding, and there are so one more thing we have learned. There are so many things in which BIM technology is lacking. GIS supplement that particular lack, those particular lackings. अब देखो building once constructed in its surrounding become an important monument for its life cycle. This we all understand that once a building is constructed, it becomes important part throughout its life cycle in its surrounding. So that's mean again its life cycle must not be managed in isolation, but with respect to all nearby existing facilities, utilities, but with respect to all nearby existing facilities, utilities, neighborhood, and topography. So in other words, we in GIS we put things like that locational aspect, where that particular building or structure has been located, that particular thing play a major role. If let's say one particular building is on the top of a hill, another same building, let's say in architectural plan, will located on the plain area, things are different. So that means that locational aspects play a major role. Okay, the locational aspect of a buildings are equally important in life cycle along with its geometrical and internal functional characteristics. So that's mean we just to consider all these things we need to have GIS. Just a few more things to support this, the use of GIS. Layout of there are so many things nowadays. Even these things are not these things are not in India, but now layout of existing facilities like electrical lines, water distribution system, sewerage network, which play a major role in locating a particular building or its life or throughout in its life cycle, play a major role, which are maintained using GIS nowadays abroad. So that means you in future you cannot neglect the surrounding to consider surrounding you need to have that GIS. So that means another thing, building life cycle specifically in hill areas where topography play a major role. Building life cycle specifically where in hills where topography play a major role should not be done or should not be managed without GIS. Okay, so topography for the topography modeling best of suited software is GIS. So for that we need to have GIS. Another further, there's another increasing need of quick and easy information retrieval mechanism. Just like let us suppose if let's say there's a particular city, Delhi. If let's say someone is not aware that Delhi is the capital of India or that India Delhi lies in India, then obviously map is in hard copy. He need to search search location of Delhi. But in the GIS, same as just like you have word file, you find a particular word with that command find. How many times that particular word appear? Same way in the GIS. If you type name Delhi, where that particular place is there, same just like Google Earth. You type name, it lead that particular location. So that is just abstract form of GIS. That means easy information retrieving mechanism, which is also available in GIS. Okay, plus provide mechanism for query and just like if let's say if you are there are drawings in AutoCAD even in BIM, if you find where is this particular room, where is that particular room, so you cannot do that. Where is this particular room? You cannot do that. But in GIS, if you find where is this place, where is this particular room, that particular type of questioning and answering is possible. If you let's say if you have data of world population in GIS, you find that how many countries have population greater than this. That is the attribute based query. So that those things are possible in GIS. Okay, so that's mean many cities nowadays, many cities have GIS-based information available typically, which include topography, vegetation, existing facilities, utilities, footprint of building, street layouts, land use, zoning, plots, okay, demographic profiles, which play a major role in building life cycle. Okay, so these all informations are available now in GIS. Those in all informations are available in GIS. So this is the reason that we need to have GIS. Okay, so GIS play a major role in planning, like let's say approach road to particular that building site, what how to bring water supply that particular location, electricity, gas, send, receiver, extra, all that particular location. Okay, so these all things that all these things help in building life cycle. So building life cycle in the different is Now this is a that building life cycle in different geographical locations have different set of challenges. In building life cycle in different geographical locations have different set of challenges in which GIS use has innovative solutions. That's why you cannot neglect GIS from the building life cycle. So keeping the importance of geographical location of a building under consideration, as well as its geometry and internal functional characteristics, BIM alone may not be the complete solution for building information modeling. The effect of geographical locations are considered using GIS, and BIM on the other hand is used for modeling of geometry of a building. Hence, BIM and GIS together may have an innovative solution. This was the conclusion from where we have started, that BIM and GIS together may have innovative solution for building life cycle. आगे चलें. ठीक है. अब नेक्स्ट है, it's not like that people have not realized this earlier. There are so many applications in which people have used this. So BIM is best to suited that we have discussed that BIM is best suited for managing information related to building. GIS on other best outside the building. So integration of BIM and GIS facilitate in understanding the effect of surrounding on building life cycle and impact of surroundings, because addition of the new building in it. So neither GIS or BIM do this on their own. Okay, so for, let us say, for this integration of GIS and BIM is required for sustainability analysis, disaster preparedness, the integration of BIM, this enables use of diverse. Now you have two databases. BIM, you have some information related to building in BIM. You have information related to surrounding in GIS. So that means diverse information data set corresponding to a building and its surrounding together in building life cycle. So this integration enable the use of diverse information data sets. This information, diverse information data set. This allow better impact of decisions. If let's say we have building also and surrounding also, this facilitate understanding the impacts of decision making on surrounding. Okay, during building life cycle, plus BIM and GIS facilitate in conveying the status of regular updates if we connect these two technologies with time. Now, there are the BIM indication provide diverse information to evaluate the developed execution schedule. People have explored this integration for execution schedule, cost of construction on a particular location. In generally, we in the books we study this is the cost of construction, but for one location this may be different, for other location this may be different. So that people have explored by considering the surroundings. So people have explored how to use this BIM and GIS together for cost of construction on a particular location, for sustainability analysis at earlier stage. So integration facilitate building performance analysis to ensure best orientation, energy analysis, and optimized design. Another applications where the BIM generates material. Now is another very beautiful application. BIM generates material requirements. You have 3D model of a building. During the construction, you can generate how much material is required. Even operation and maintenance stage also, you can generate a material requirement. Depend whether you are doing whitewashing or some repair work. You even during the demolition stage. So that means from the building model, material requirement during construction, operation and maintenance, and demolition stage may be generated. And GIS help in optimizing the transportation of material from different locations, keeping transportation cost into account. So this integration also optimize waste reuse. These are the applications which have been reported in the various literature. So this waste reuse, recycling to minimize waste, optimize overall energy cost, minimize demolition time and impacts on surroundings. BIM is in another very important application, geo-referenced mean latitude and longitude of a particular building. If let's say it's a building know its latitude and longitude. So that means BIM in general is not concerned with geo-referenced virtual model. However, integrated BIM and GIS address outside and building under construction. So mean you can assign latitude and longitude to that particular building so that anyone when open, it goes to respective position in on the globe. हेलो, आवाज आ रही है?
Yes, sir.
Yes, sir.
किसी को यहाँ पे कुछ पूछना हो या कोई कुछ? चलो ठीक है, फिर आगे चलते हैं. अब देखो, now let us suppose now building life cycle. A building life cycle, we have divided this life cycle into 6 stages. First feasibility, then after that design, planning, construction planning, then construction, then operation and maintenance, and demolition. Now what we will discuss, now we will just see only, now I will not discuss, I will just see what are the different applications which have been reported by these two technologies in these 6 stages. I repeat, now I will just list down all the applications. So first application of BIM in different stages. First is application of BIM in different stages. So first let us start from the feasibility stage. In the feasibility stage, application of BIM has been reported for sustainable development, daylight simulation for orientation. In the design stage, BIM applications have been reported for structural design, sustainable building design, climate-based daylight simulation for building design, energy and thermal analysis and building design. In the planning stage, for quantity takeoff, cost estimation, construction scheduling, 4D modeling, constructability analysis, site layout planning, workspace planning, and construction safety planning. In the construction stage, carbon emission reduction, clash detection, construction defect reduction, construction progress monitoring, construction quality assessment, safety planning during construction, sustainable construction planning, as-built documentation, deviation analysis. During the operation and maintenance stage, the application of BIM, which have been reported worldwide in the various research publications, indoor navigation, identification of building component, interior space analysis, maintenance and refurnishment, renovation and retrofitting, evacuation planning management. Then last, demolition, waste minimization plan. Now application of GIS in the different stages. Now these are the areas in which BIM is lacking mainly. So now GIS is supplementing this area by site selection, sustainable site selection. Preliminary survey and modeling of regulatory requirements, planning for extending utilities facility to a site, surface and subsurface conditions. In the design, we will not find reported applications of GIS for the design application. So for just to include public participation in planning and design. Now in the planning stage, GIS use has been explored for construction cost, screening out of contractor to execute or to determine their competency to do work for a particular location. Construction scheduling and 4D modeling, location-based planning and scheduling, time-space conflicts, planning for safety and low disturbance. Now, application of GIS in the construction stage. Construction material trading, material layout planning, layout of facilities on job site, dynamics, progress control. The application of GIS during the operation and maintenance stage, maintenance program on distributed site, or automated drainage analysis. Then demolition means distribution of construction equipment on various sites. And third, first we have discussed that how BIM is being used in the different stages of building life cycle. Then how GIS is used in the different stages of building life cycle. Then people have explored the integration of BIM and GIS in different stages of building life cycle. Just like first data integration. Just the way we have discussed that you have two types of data related to building and surrounding on a common platform, and that data can be used for so many decision making. Preliminary cost estimation, planning sustainable built environment, subsurface, utility visualization, view coverage, and shadow analysis. Then the design stage, design for low energy consumption and development of specific function in planning and design, which relate to sustainability. This integration has been explored for construction planning, the planning stage, visualization of construction process, and indoor geovisual analysis. Then in the construction stage, supply of construction or construction supply chain management, optimizing location of equipment on site, load distribution in construction, ensuring safety during construction, and knowledge process of building and documentation of construction projects. Now, during the operation and management stage, this integration has been explored for integrated pre-retrofitting, reuse of existing facility, flood damage assessment, specific assessment, monitoring, historical and bad management. Last in the demolition stage, building construction waste management and seismic damage assessment. Now, just I will just show you this very small example how to model topography. This is the flow chart of this process. Okay. So topography first. Now, just small example that how the topography of INIT Hamirpur has been modeled. Okay. First step was to develop. I repeat again, in the topography modeling, we have two steps: modeling of existing facilities utility which lies on the surface and modeling of surface. Okay. Just to model surface, first step is survey the total station. Okay, so data from the total station was transferred to list CAD. Then after the list, after this data, it goes to the AutoCAD, and from the AutoCAD, that data was transferred to the ArcGIS as a geodatabase. Now, from there, it was converted into the this save file, 2D save file. Now, this is the points which were taken with the help of total station on NIT Hamirpur surface. Now, after that, elevation Z value was assigned to all these points. Now, after this Z value, these are all those points which are now in space. Now they have X, Y, and Z coordinates. Now these points are in space. Another view of the same points in space. Now, after that, from those points, we have generated surface. This is the surface of NIT Hamirpur in that that I have shown in the top view 2D in the 2D. Another there are the two way. Another is raster, and another one is team. So these are the widely used term in GIS, but we will not go. But this now for the time being, you just keep in mind that there are the two way. This is the thin triangulated regular network. Now these are the two possible way to represent the surface. Now same surface in 3D. If you are in a position to see these are the this is the ground. This is the ground here. This is the ground. Now this is the image that now I will place this image over the surface. Now when this image is placed on the surface, now you see surface is in 3D. Okay, but now closer view of that 3D surface. This is the ground. Now modeling of facilities. Yes. Now facilities have been modeled because those have been digitized. Now these are the footprints now of building which lies. Then these footprints were placed on its respective position, and these footprints were exported into the SketchUp. There in the SketchUp, 3D models were made, and then from those, after those all footprint when complete 3D models are made in the SketchUp, those are brought to their respective location. So those are placed on this surface. These are the 3D models of the buildings which have been developed in the SketchUp. Those are now placed. This shows the road network also. Now we will place this. Now see here, all these things are together. Surface, all the surface, these buildings, and on the buildings we have the facilities. These are the views. from the different direction and angles. Now this is the virtual model. Now this is the virtual model once constructed. Now this virtual model can be used to this virtual model can be used to plan a new addition in this particular campus. Another view. Now there are so many analyses which can be done on this virtual campus. Just like location based, if you find very civil department, it will just go to the civil department. It will highlight civil department. That is location based selection, area based selection. If you find out, let's say within, let's say 1 kilometer around this building, how many buildings are there, that is the area based selection. This area based selection highlights all the facilities component after specified districts, or calculation of area and volume, area and volume. You can calculate that area, surface area. It may be area may be on the surface or projected area just on a plane, or volume of cut and fill, a volume occupied between two surfaces, just like if we do excavation, or volume between surface and the reference plane. This also have computation of excavation between a plane and a surface. Profile along the line, just like if you this is a surface, you draw a line, you can find out profile. Control along the line, specify location. If you let's say if you for the road planning, if you click a point, line joining the point from open visual, this portion is not visual, just like here. If you move toward this side, this portion, which is this is a hilltop here actually. So which portion is visual, which portion is not visual. Visibility analysis. Runoff analysis being, let's say if let's say this is a water tank location, let's say somehow because of accident this tank blast, that from where that water will go outside, that's a one direction. Sunlight visualization also, and string identification. So there are so many applications of this particular, or this has been used to find out check dam location for like on a Mirpur, like these are the locations of check dam, drainage basin to develop drainage basin maps. Okay, artwork planning that this particular building is to be from where cutting will take place, filling will take place, and how much will be the volume of that cutting that need to be done. So identification of location for dumping site or nearby location for dumping of this material. Okay, so that this is the just here last example. That this is the electronics block, modeling of electronics block. That block modeling is done in Revit or in BIM, you can see, and that block electronics block has been placed in its surrounding. Okay, so building with its surrounding to facilitate entire life cycle. And okay, at last, if I conclude, the interaction among existing and proposed facilities or structure and their environment impacts are important aspects to be considered for coordinated, integrated, and sustainable. I repeat, interaction among existing and proposed facilities and their environmental impact are important aspects to be considered for a coordinated, integrated, and sustainable solution. It is like judgment in a monodisciplinary to multidisciplinary aspects. So the use of BIM and GIS together provides a multidisciplinary approach for collaborative and sustainable development. Okay, I will stop it here. Now, if you have any question, now you are free to ask.
Dear participants, if you have any query and want to interact with our speaker, Dr. Vijay Kumar Bansal ji, please ask your queries. Okay, so I think participant needs some time to ask queries to you, sir. So we can share your contact detail with them if they contact
Okay.
us in the future. And also the contact details are available on NIT Hamirpur website. So they may contact directly to the sir or through us.
Okay. Thank you, Vimal. Thank you for giving me
Thank you,
this
sir. Thank you
opportunity.
very much for giving this comprehensive lecture on BIM and
ठीक है,
GIS.
मैंने थोड़ा सा मीटिंग है विमल, है ना, 15 मिनट, है ना, मीटिंग के लिए कोई मैसेज आ रहे थे ऊपर से, इसलिए मैंने थोड़ा 15 मिनट शॉर्ट कर दिया, है ना.
Okay, okay.
But thank you very much for this opportunity, and thank you all.
Okay, thank you very much, sir. So,
Okay.
presenting this lecture in this 5 days ESTC. This is really a very good lecture. Thank you very much, sir. Okay, dear participants. So, next lecture in the series of 5 days lecture will be presented by Dr. Souvik Chakraborty. He is the faculty in the Department of Applied Mechanics, IIT Delhi. I hope the lecture is going to be very good. The next lecture. And so again, we will meet at 1 p.m. Okay. Thank you.